assistant,
Emily.
We are here together today to tell you about a few of the experiments we will be using at the Wacky Wonders of Science Clover Kids Camp. Emily, can you tell me how many kids we usually have at Clover Kids Camp per year?
We average about 50.
We average about 50 kids. Emily, I'm going to ask you a very peculiar question. If you saw a young lady or a young woman walking down the aisles of a grocery store, and they stopped in the aisle, picked up some baby diapers, went down another aisle, picked up some baby formula, what would you think?
They have a baby.
Hypothesis! That is a great hypothesis! That is an educated guess. An educated guess is a hypothesis. In science, scientists use educated guesses or hypotheses all the time. Emily, would you step over here? I would like you to put your hands over here. I am going to sprinkle this powder on your hands. Now I'm going to dump some water in here. What would be your guess?
It's going to flow out.
Emily, what is happening? Oh my goodness, snow! Snow! How does it feel? Does it feel cold? Does it really feel cold? And Emily, how did that happen?
Because it's a polymer.
What is a polymer?
A chain of molecules.
A chain of molecules. All right, and this chain of molecules absorbs water, so these tiny crystals formed into snow and it's still cold. What do we have next?
This is a grow creature.
What is a grow creature?
Well, it's a creature that on the first day you trace it, then you write down the measurement, then you throw it back in the water for 24 hours, and then you measure it, do the same thing for the next few days.
Is that a polymer also?
Yes.
It absorbs water? Oh, what do we have here? This is very interesting. What is this? This is beautiful.
It's a rainbow tube.
It's a rainbow tube. Can you tell me how you made the rainbow tube?
Well, in the rainbow tube, we got these jelly crystals.
Jelly crystals. What? They look very, very small. And then how did they get to be large like this?
We put them in water.
And they absorbed water and they are a polymer too? Oh my goodness. So how did they get to be colored?
Well, they already came colored.
They came colored? Oh, you can buy them plain or colored. Well, if these are all polymers, but these are fat, these look different than the alligator when he grows and they look different than the snow. How is that?
They link in different, because they link in different ways.
Oh, so like if I had chains of molecules and I had a magnet, they would link like this. This is an example, and then maybe sometimes it would link like this or this, and that's why they're all polymers. All right, Emily, what is this we have here?
This is a lava lamp.
Okay, it looks like we mixed two ingredients, the water and the oil. And Emily, where did the water go when we poured the water in?
To the bottom.
The water, why did the water go to the bottom?
Because it is heavier and more dense.
Oh my goodness. So let's put a few little drops of food coloring in there. And now we're going to make it like a lava lamp. Look at that. The food coloring. Where is it going?
To the water.
It is going, it will eventually, I think we need to put a few, oh, there it goes. It is dropping. That means it is also more dense. Put some tablets in there and let's see what happens. We are mixing two or more substances, adding another substance, and what are we getting? Oh, it's bubbling just like a lava lamp. Oh my goodness, when you mix two substances and get another substance, what do you call that?
It's a chemical reaction.
Oh, awesome. When that reaction stops, we will put the lid on, and then we will have blobs of oil and blobs of water. And when oil and water do not mix, what do you call that?
It's immiscible.
Unmissable. Very good. Okay, Emily, let's go to the next thing. Oh, I see this awesome big balloon. How many breaths do you think it will take me to blow up this balloon?
About 30.
About 30? Well, you hold that in tight for me, would you? Emily, how many breaths did it take me to blow up this balloon? One breath. Do you know what? This is called the Bernoulli principle. And when you hold the balloon way away from your mouth, the air pressures around it will draw the surrounding air into it. Besides just your one breath, if you hold it up here, only your breath can get into it. That is an awesome trick. That would be very helpful if you're going up there and big. What is this thing?
This is a Cartesian diver.
Cartesian diver. What happens when you squeeze it?
It sinks.
It sinks. Why does it sink?
Because it is heavier or more dense.
All right. You know, for older kids, they could do this little hook and dive thing and try to hook the little loop there. But for younger kids, we made a variation. And why did we make a variation?
Because it might be harder for them to hook it.
So they jump down and predict which color that would hit. Okay, we make the diver with an eyedropper, a hex nut, and a wire. Okay, what do we have here?
That's a screaming balloon.
Why does this balloon scream?
Because of the friction.
The friction on it and the different shape of the hex nut. What would happen if we would use the penny?
It doesn't make any noise.
Okay, it doesn't because of the difference in the friction. Where would you use this in everyday life?
For a play.
And make a noise effect? Sound effects? Oh, maybe how about Halloween, a spooky effect. What is this? A wind wheel? Well, how would we use a wind wheel?
To create energy.
Create energy. You put this down in the ground and the wind catches it and it makes energy. What in everyday life would be like that?
A wind turbine.
A wind turbine. Okay, we're going to end our camp with the Mento geysers. Okay, Emily, why did we choose to use a small bottle instead of a large bottle?
Because we are on a tighter budget.
Okay, let's put the Mentos in there. Okay, pull the plug, Emily. And what happens? Ah! Mr. Spangler, we would like to thank you for all these experiences. We would love to get your money so we can buy some snow, some crystals, and some growing gators. Thank you, Mr. Spangler.